Hey everyone, today we're diving deep into one of the most sophisticated cyber threats out there right now, a self-propagating digital worm. This thing is nasty. It turns the very foundation of modern software, the supply chain, against itself.
You know, it all kicks off with this idea that sounds totally backwards at first. The security firm UpGuard once said, cybercriminals are surprisingly lazy. And that really is the perfect way to frame this. See, hackers aren't trying to storm the castle walls. They're looking for the easiest path to the biggest prize. It's all about maximum impact with minimum effort.
And that's exactly where the supply chain attack comes in. Instead of targeting one heavily fortified company, attackers just poison the well that everyone drinks from. They sneak their malware into a trusted piece of software, an open source package that millions of people use, and then they just sit back and let it ride right through the front door. It's delivered by the very developers who are meant to be protecting the system.
Which brings us to our case study. Let's get into the nitty-gritty. We're going to look at a piece of malware known as Shai-Hulud 2.0. And trust me, it is a perfect and frankly terrifying example of a modern, self-propagating supply chain worm.
So, picture this. It's late 2025, and this worm starts spreading like an absolute wildfire through the NPM software registry. Now, if you don't know, that's a massive library of code that millions of developers rely on every single day. And this worm's mission? It was brutally efficient. Just steal as many credentials as humanly possible.
And the scale, it was just staggering. In a really short amount of time, the worm compromised about 700 different software packages. That then spawned over 25,000 malicious code repositories on GitHub. And the end result of all this? Over 400,000 developer secrets. We're talking the keys to the kingdom. We're just out there, exposed. It shows you the insane exponential power of an attack like this.
So, how'd they pull it off? Well, the infection chain was just deviously clever. It all started when they snuck a malicious pre-install script into a legitimate software package. Now, when a developer went to install that package, the script would run. And here's the sneaky part. It would first check to see if a popular developer tool called Bun was installed. If it wasn't, the script would just install the real, legitimate version of Bun. Nothing to see here, right? But once Bun was there, the attackers used it to secretly execute their real malicious payload in the background. It was the perfect camouflage.
And what was that payload after? Oh, just the crown jewels of pretty much any modern company. We're talking GitHub access tokens, which give you full control over source code. We're talking AWS and Azure credentials that control cloud servers, databases, the whole shebang. Google Cloud keys, and this is the really crucial part, it stole NPM tokens, which allowed the worm to infect more packages and just keep on spreading.
But here's where it gets really ingenious. To make sure it could stick around, the worm turned every infected machine into a secret, self-hosted GitHub runner. Basically, it turned every computer into a tiny little spy server that the attackers could control. This created a super stealthy backdoor. They could run any command they wanted just by using GitHub's discussion feature. It's a method that completely bypasses most normal security.
But believe it or not, that wasn't even the craziest part of this attack. No. The real twist was that it created this high-stakes paradox that literally turned the standard cleanup procedure into a weapon against the victims.
Okay, so let me ask you this. Put yourself in this situation. You're a security engineer. You discover thousands of public code repositories leaking your company's most sensitive secrets. What is your first gut instinct move? What do?
Your first thought is delete them, get them offline now, right? Of course it is. But that's the trap. That is exactly what the attackers were counting on. They built in what's called a dead man switch. The malware was constantly checking its connection to those GitHub repositories. If you deleted them and broke that connection, it would trigger a destructive payload that wiped all user data on every single infected machine. The very act of cleaning up would cause catastrophic damage. It's diabolical.
So the correct response, it was so counterintuitive. It wasn't deletion, it was privatization. By changing the repositories from public to private, security teams could contain the leak, they could stop the bleeding without severing that connection and tripping the wire. It's an incredibly subtle solution to a really, really dangerous problem.
Okay, wow. So with a threat that sophisticated, how on earth do you defend against it? Well, it's really about moving from that state of reactive panic, that delete everything impulse, to a proactive, hardened security posture.
And you know, a huge part of this isn't even about fancy tools. It's about culture. A developer on Reddit put it perfectly. They said, the culture of grabbing tiny dependencies for trivial tasks really amplifies the supply chain risk. And they just hit the nail on the head. Our entire ecosystem is built on this web of third-party code, and we've gotten so used to just trusting it.
So what are the big picture strategies? First, something called a zero-trust architecture. The philosophy is simple. Trust nothing, verify everything, always. Second, companies need to use an internal, curated registry. Think of it like a bouncer for your code. Only approved, vetted packages get in. And third, you have to enforce the principle of least privilege. That means even if a token is stolen, its permissions are so limited that the damage it can do, the blast radius, is tiny.
And for the developers out there, the folks in the trenches, there are things you can do tomorrow. Mandate phishing-resistant multi-factor authentication on everything, no exceptions. Next, disable those automatic install scripts that this worm took advantage of. Also, run your package installations inside sandbox containers that have no access to your network or your secrets. And finally, just be patient. Vet new packages, give the community some time to find the bugs and the worms.
All of this really points to a new reality. We're all navigating a zero-trust ecosystem now. The old rules, the old idea of a trusted perimeter, it just doesn't apply anymore. Every single piece of code is a potential threat.
And if you think this is some niche problem, the stakes couldn't be higher. The forecasted annual cost of software supply chain attacks is a staggering $60 billion. This isn't just a technical problem anymore. It's a massive economic and strategic threat. Which leaves us with a really fundamental and kind of scary question. In a digital world that we have built on the amazing idea of sharing code, of collaborating, of standing on the shoulders of giants, who can you really trust?